Students, now we are in the chapter quadratic expressions. Quadratic expressions. In yesterday class, we have completed exercise 3a and exercise 3b concept of theorems we have discussed. Let us going to discuss today. Last theorem depends upon the quadratic equations and inequalities and depends upon the roots concept a theorem is there. Let us going to discuss about the theorem. Theorem 3. Yesterday I said two theorems. This is theorem 3 and this is also IMP concept. Depends upon this concept, functions, domains and algebraical sums and algebraical inequalities are depends upon this theorem only. IMP concept like A comma B comma C belongs to R. A comma B comma C belongs to R such that A comma B comma B belongs to R such that the equation ax square plus bx plus c is equal to 0. Ax square plus bx plus c equal to 0 has real roots alpha and beta. Here the main point is that alpha less than beta. Alpha comma beta with alpha less than beta. Then first statement for alpha less than x less than beta, ax square comma bx plus c comma a have same sign. Ax square plus bx plus c comma a have opposite sign. Opposite signs. Second one, for x less than alpha comma x greater than beta, ax square plus bx plus c and a have same sign. This is the statement of the theorem. Here ax square plus bx plus c comma a have opposite sign and same sign concept. Let us discuss about the theorem. Depends upon the quadratic equation. We know that I am writing ax square plus bx plus c is equal to a into x minus alpha into x minus beta. We can write a into x minus alpha and x minus beta. While we discussing the concept of quadratic equation, then only I said this theorem. This formula ax plus bx plus c can be written as ax square a into x minus alpha and x minus beta. Right, like this ax square plus bx plus c by a is equal to x minus alpha into x minus beta. Now we can write here, try to understand case alpha less than beta and alpha less than x less than beta is there. I am writing case 1 alpha less than x less than beta. Let alpha less than x be right. That implies we can understand alpha minus x less than 0. That implies x minus alpha greater than 0. Also, in the similar way, here you can write whenever alpha less than x less than beta, here x less than beta you can write x less than beta So we can write x minus beta less than 0. What is happening here? X minus alpha, that implies you can write now x minus alpha into x minus beta. X minus alpha became positive and x minus beta became negative. Positive into negative becomes less than 0. Positive into negative I am writing. Positive into negative is equal to negative. That concept used here. So x minus alpha and x minus beta less than 0 we got here. So we can understand ax square plus bx plus c by a becomes less than 0. That is negative. Negative means you can understand as ax square plus bx plus c by ax square plus bx plus c by a we can understand as positive by positive negative or negative by positive is equal to you can write positive by negative or negative by positive. Positive by negative or negative by positive. Therefore, you can understand here ax square plus bx plus c comma a have same opposite sign. Ax square plus bx plus c comma a have opposite sign. If opposite signs if alpha less than x less than beta. That the meaning is that here we got x minus alpha and x minus beta less than 0. Here we got alpha less than x less than beta. Plenty of times we have discussed in first inter and 10th class and 9th class also. If x minus alpha and x minus beta less than 0, then x lie between alpha and beta. This is the proof. X lie between alpha and beta, meaning this one alpha less than x less than beta. Now case 1 completed. Let us discuss about case 2. For case 2 also you can write this one as ax square plus bx plus c by a is equal to ax square plus bx plus c by a is equal to x minus alpha into x minus beta. X minus alpha into x minus beta. Now among this one we can write if, otherwise let x less than alpha. Here because he is asking this x less than alpha. Whenever x less than alpha, the template you can understand x minus alpha less than 0. Keep aside x minus alpha less than 0. Whenever, since you can write now, since alpha less than beta, alpha less than beta. So alpha is smaller value than beta. Whenever alpha less than beta, we can understand x is also less than beta because x is smaller than alpha, so alpha is smaller than beta, so beta is bigger than x. If you are having any doubt, try to understand this one. X is a 2, a number 2, and this is 3, this is 5. 3 less than 5, 2 less than 3, then you can understand 2 less than 5. In the similar way, since alpha less than beta, you can understand x less than beta. Whenever x less than beta, you can write x minus beta lesser than 0. That implies, I want to say with you that x minus alpha into x minus beta becomes positive. X minus alpha into x minus beta becomes positive because you can write this one negative into negative. Negative into negative is equal to positive. The concept we use, negative into negative equal to positive here. So therefore positive we got ax square plus bx plus c by a we got as greater than 0. Whenever ax square plus bx plus c by a greater than 0 we can understand this as ax square plus bx plus c by a is equal to positive by positive or negative by negative. Positive by positive or negative by negative. Therefore ax square plus bx plus c comma a have same sign. Ax square plus bx plus c comma a have same sign. That one keep aside. Another case is also there. because we did not use here x greater than beta, that is case 3. X less than alpha depends upon x less than alpha, we have used alpha less than x less than beta also. In the similar way we can understand here x greater than beta. Put here x greater than beta. Whenever x greater than beta, you can write x minus beta greater than 0. X minus beta greater than 0. Now, since you can write alpha less than beta, whenever alpha less than beta, try to understand here x is bigger than beta. Whenever alpha is smaller than beta, then you can understand x is most bigger than alpha. So, whenever x is most bigger than alpha, you can understand x minus alpha greater than 0. That implies we can write here x minus alpha into x minus beta greater than 0. X minus alpha and x minus beta greater than 0. That implies you can understand this is positive. Ax square plus bx plus c by a greater than 0. This is greater than 0 concept is positive by positive or negative by negative. Positive by positive or negative by negative. Therefore, we can say here ax square plus bx plus c comma a have same sign. Ax square plus bx plus c comma a have same sign. Have same sign when x less than alpha and x greater than beta. Whenever x less than alpha and x greater than beta, we can understand that ax plus b plus c comma a have same sign. This is the most IMP theorem. Depends upon this theorem, we can understand here whenever x minus alpha into x minus beta greater than 0, plenty of times we have discussed that x does not lie between alpha and beta. That only indicates this one x less than alpha and x greater than beta. This indicates x less than alpha and x greater than beta means there is no x value between alpha and beta. Whatever the value lesser than alpha, there the x value exists, and whatever the value greater than beta, there the x value exists. So we can understand that the formula depends upon progression, depends upon functions concepts, domains concept, algebraic concepts and inequality concepts. For all those things, this is the main important concept. Whenever x minus alpha and x minus beta less than 0, the value x lie between alpha and beta. Whenever x minus alpha and x minus beta greater than 0, then x does not lie between alpha and beta. Plenty of times we discussed. Now let us go and discuss about another theorem and a characteristic of the graph of the quadratic expression. Let us discuss theorem 4. Theorem 4. If a greater than 0 for a quadratic expression f of x is equal to ax square plus bx plus c, it has absolute minimum at x is equal to minus b by 2a, and minimum value or absolute minimum value is equal to 4ac minus b square by 4a. This is the first case. In the theorem, this is second case. If a less than 0 for a quadratic equation f of x is equal to ax square plus bx plus c, it has absolute maximum it has absolute maximum yet x is equal to minus b by 2a, and maximum value is equal to 4ac minus b square by 4a. This is the theorem. Proof is also so easy. Proof. Let given quadratic expression we can write as f of x is equal to ax square plus bx plus c. We can use the minima maxima concept to find f of x is min or max. To find f of x is minimum or maximum, we should calculate the first derivative is 0. Simply you can write f dash x is equal to 0. Calculate the f dash x. F dash x, derivative of the function ax square plus bx plus c equal to 0 is here 2ax plus b equal to 0. You can understand this one as 2ax equal to minus b and x is equal to minus b by 2a. So we got here yet x is equal to minus b by 2a, whether the function is min or max. But x equal to minus b by 2a decides the function whether it is min or max. Now we can understand f double dash a, f double dash x I am writing 2a. You can understand that if 2a we got, but we don't know that whether the a is positive or negative. If a is positive, whenever a is positive, 2a is positive, 2a greater than 0. Whenever f double dash x greater than 0, then the function is minimum. We know that in first year concept. If a less than 0, then it becomes minus 2a. So minus 2a less than 0. It becomes whenever f double dash x less than 0, then the function is second maximum at the given function. To get the min or max, you can substitute the same value in the function f of x. Now you write if a greater than 0, f double dash x is equal to simply 2a greater than 0. Whenever f double dash is greater than 0, f of x is minimum. You write f of x is minimum. And simply you can write if a less than 0, f double dash x is equal to minus 2a. That is less than 0. Therefore, f of x is maximum. F of x is maximum. To get the minimum value or maximum value, to find extremum, you can understand. Extremum means min or max. Whether the function is min or max, they said this one f double dash x. But min or max value is the same. Min or max, you can write f of minus b by 2a. Whatever the value is deciding whether it is min or max, you can substitute in this f of x. So substitute here. Instead of x, you can substitute minus b by 2a whole square. A into minus b by 2a whole square plus b into minus b by 2a plus c. That is equal to, right here, a into b square by 4a square. A into b square by 4a square minus b square by 2a. Minus b square by 2a plus c. A will be getting cancelled. A is like this. B square by 4a minus b square by 2a plus c. Yeah. Take an LCM, you can get b square minus 2b square plus 4ac. Whole by 4a is LCM. Therefore, you can conclude min or max, anything. Min or max value is equal to, first of all, you write plus value 4ac minus this is v square minus 2v square becomes minus v square by 4a. 4ac minus v square by 4a is the extremum value, whether it is minimum value or maximum value. The function whether it is min or max, decide the second derivative. If a greater than 0 it is minimum, and if a less than 0 it is maximum. Now let us discuss the characteristic of the graph of the function depends upon the extreme values. The characteristic of the graph. Now we can write characteristics or nature. Nature of graph of QE ax square plus bx plus c, or it can be written as f of x. The function f of x, ax square plus bx plus c graph. Case 1 and right. Draw like this. This is y axis, this is x axis, this is x dash line, this is y. Like this you can write. This is the value. Here I am writing delta greater than 0, a greater than 0. Whenever a greater than 0, we thought that it is the value having the minimum value yet, it means minus d by 2a, and the minimum value is 4ac minus b square by 4. That is the minimum. There is no maximum of the curve in 10th class. From the graphs, it represented a parabola. There is no end point of the parabola. You will be knowing the characteristic and nature of the curve of the parabola. It is an unbounded curve. There is no limit. Unbounded, unlimited curve. So minus b by 2a and 4ac minus b square by 4a is the minimum point of this graph. Delta greater than 0 indicates there are two real and distinct roots. Whenever there are two distinct roots, a graph intersects the x-axis two distinct points. Whenever the graph intersects the x-axis two distinct points, there are called as points of intersection. You will be learning in geometry also. In advanced sums are there the concept. Here two points are there. You can put AB. Here you can put AB also. So here you can write the characteristic. If a greater than 0, comma delta greater than 0, the graph intersects x-axis in two distinct points. The graph intersects x-axis in two distinct points. The minimum value is equal to 4ac minus b square by 4a. Yet x is equal to minus b by 2a, you can write. At x equal to minus b by 2a. And you can say that there is no maximum value. There is no maximum value. That's all. Case 2. Delta is equal to 0, comma a greater than 0. The characteristic is like this. You can put like this. Of course, like this also. There is no question of touching at 0 comma 0. Here you can put minus 3 by 2a comma 4ac minus b square by 4a. Students, you need to understand that this is 0 because on x-axis y is equal to 0. Whenever delta is equal to 0, we know that b square minus 4a is equal to 0. Automatically 4ac minus b square by 4a is equal to 0. But sir, why did you write this? Simply to make that this is the minimum value. To say the concept that this is the minimum value for a minus b square by 4a is the minimum value of the curve at x equal to minus b by 2a. I want to discuss with you. If next step I am writing, if a greater than 0, if a greater than 0 comma delta is equal to 0, the graph or the graph touches x-axis. The graph touches x-axis. Because delta is equal to 0 means there are two roots, that two equal roots. That is why simply two roots became a root, therefore the secant became tangent. So according to geometry concept also it is correct. Touches x-axis. There is no question of two distinct points. The same concept, the minimum value is 4a minus b square, everything okay. There is no maximum for this also, there is no maximum value. There is no maximum value. Case 3 I am writing. Case 3. If a greater than 0 comma delta less than 0. Whenever delta less than 0, there are roots are non-real complex numbers are imaginary roots. Whenever imaginary roots, we can say that there is no line intersect or touch the curve. Whenever there is no line intersect or touch the curve, we can say there is no point of intersection. The graph neither touches nor intersects. The graph neither touches nor intersects x-axis, nor intersects x-axis. The shape will be like this. Simply leave it. Like this. For anything you can write this one minus b by 2a comma 4ac minus b square by 4a. Now you can say that the graph lies entirely above x-axis. The graph lies entirely above x-axis. There is no maximum value for this also. There is no maximum value. For this curve also, there is no maximum value. For a greater than 0, we have arranged three cases here. We have discussed it. First one is delta greater than 0, second one is delta is equal to 0, third one is delta less than 0. In the similar way, we can discuss the characteristic of the same curve, the same graph for a less than 0 concept. Case 1. Another Roman number 2 you can put. Now you can write a less than 0. Let us draw the diagram first of all. Draw like this. Draw like this. This is y-axis. Put here a and b. What is happening? This is a less than 0 concept. Means a less than 0 means negative. The graph will be negative side. So if you can write here if a less than 0 comma delta greater than 0, the graph intersects x-axis to distant points. It's okay. Here you should write the maximum value. The maximum value, not minimum. Maximum. Don't understand that students this is minimum. This is maximum. Try to understand from minus to plus. This is downwards. In the downward curve, you can understand here going upside. This is maximum. There is no minimum. Until which depth the graph is going on, we cannot say properly. That is why you can understand there is the maximum value 4ac minus b square by 4a and there is no minimum value. We cannot say the minimum value. There is no minimum value. Next one, second one, case 2. Case 2. Draw like this. The condition A less than 0, comma, delta is equal to 0. The graph touches y-axis exactly correct. There is no x-axis, and it is here you can say the curve is called as a downward parabola. The curve is a downward parabola. There you can say the curve is upward parabola. You can write it. The curve is here. The curve is an upward parabola. Whenever a greater than 0, the curve is called as upward parabola. And whenever a less than 0, the curve is called as downward parabola. Downward parabola. And now case 3, a less than 0, delta less than 0, the graph neither touches nor intersects x-axis, and the curve is downward parabola. Draw like this. There is no question of intersection, there is no question of touches. The graph lies entirely, you can write here, below x-axis. The graph entirely below x-axis. Simply meaning the same, simply the meaning is if a less than 0, the graph is downward, and if a greater than 0, the graph is upward. Same characteristic for everything. Delta greater than 0, distinct points, and intersecting at two distinct points. Delta is equal to 0, simply touching. Delta less than 0, no touching, no intersecting. That's all. Below axis there is no maximum value also. Here you can write the graph is downward parabola. Cut it this. For everything, delta if a less than 0, graph is downward parabola, and a greater than 0, the graph is upward parabola. Now we can write the characteristic or nature of a curve. Depends upon the values. Depends upon the a greater than 0 and a less than 0 concept separately, and we should write a characteristics that depends upon the x-axis y-axis concept. Nature of curve f of x is equal to ax square plus bx plus same. Nature of curve ax square plus bx plus c equal to. First you can understand this one as the curve maintains. Of course here maybe I am not sure that the curve is passing through origin. Here you can understand plus plus, just an example I am saying you. Plus plus and minus plus, that's all. If a greater than 0, don't put 0 here. I want to discuss with you here. If a greater than 0, that's all. If a greater than 0, the curve we have learnt that is upward parabola. Whether it is depends upon delta, whether it is touches or intersect or neither touches nor touches, this depends upon the delta is equal to 0. Now we can discuss that if x approaches minus infinity, you can understand, if according to plus plus minus plus this concept, you can write if x approaches. If x approaches minus infinity, then what is y becomes? If you put minus also, you are getting plus. Then you can say f of x, that is the curve or y approaches plus infinity. Right, simply plus infinity. And if x approaches plus infinity also, you can write f of x approaches plus infinity. If in the same way you can write if x approaches plus infinity, because plus concept, put comma here, and you can write f of x approaches plus infinity only. And the third point, you can write if x is equal to minus b by 2a. F of x is equal to, it is a rule that f of x is equal to 4ac minus b square by 4a. F of x is equal to 4ac minus b square by 4a. Next one, you can write that when this is the first point, second point, third point, fourth point. When x approaches, x increases, when x value increases from minus infinity to minus b by 2a, then f of x increases, then f of x decreases, f of x decreases from plus infinity to 4ac minus b square by 4a. Here we know that students, if you are substituting minus here, this is the curve coming like this. Here minus, so much value is there left side, because minus you can substitute here also. If you are substituting here, it is going to approach here this value minus b by 2a, minus infinity to minus b by 2a. Minus infinity value may be plus infinity here. Next minus infinity minus 1 plus infinity minus 1, like that. It is going to be down. If you substitute a minus infinity, minus infinity becomes plus for this side or this side. So what is happening here? The value is decreasing from infinity to 4ac minus b square by 4a. 4ac minus b square by 4a is the minimum value here. And next point, also this plus side you can write. If fifth point, if x increases, plus side concept, and if x increases from minus infinity to minus b by 2a, students, you can understand that minus infinity is so large, lesser value than minus infinity. So whenever example you can understand this is minus 10 and this is a minus 2. Minus 10 is so smaller than minus 2. So whenever minus 10, next step minus 2, it is going to be minus 9, minus 10, minus 9, minus 8, minus 7 like that. So it is called as increasing way. If x increases from minus infinity to minus b by 2a, so plus side I want to discuss with you. Then f of x decreases. 4ac minus, so this is minus 2 plus this. Then f of x is decreases is okay. It is increase only, correct. Now it is increase. The f of x increases from 4ac minus b square by 4a to infinity. This side plus. For increases, we can use increase concept, and for this one also minus 2 plus increases, this value will be decreasing from plus infinity to 4ac minus b square by 4a. In the similar way, this is Roman number 1 students. Depends upon Roman number 2 graph. Try to understand like this, draw like this. Here you can put minus b by 2a comma 4ac minus b square by 4a. This is upward parabola. Here we can write a greater than g. Yes, I have written the concept a greater than 0. Now Roman number 2, the characteristic of the graph, we can say a less than 0. For the a less than 0 graph, we can say if x approaches minus infinity, because here you can understand it is minus comma minus concept, and here this is plus comma x is plus and y is minus. Minus comma minus concept, plus comma minus concept. So we can understand here if x approaches minus infinity, comma f of x also approaches minus infinity. F of x approaches minus infinity. Next one, say depends upon this one. If x approaches plus infinity, then f of x approaches minus infinity. That's all. Because plus minus concept and minus minus concept. F of x approaches minus infinity. This is the first point. This is second point. This is third point. And third point, if for everything this is okay, student, for every graph whether it is downward parabola or upward parabola, we can say if x is equal to minus b by 2a, then f of x is equal to 4ac minus b squared by 4a. Next point is that depends upon the characteristic of this downward parabola. When x increases to, when x, if x increases from minus infinity to minus b by 2a, then f of x increases, from minus infinity, because both are minus infinity to 4ac minus b square by 4a. Try to understand minus concept. Next the bit is that if x increases from, so plus minus concept, x increases from minus b by 2a to plus infinity, then also f of x is decreasing, so going downward 4ac minus b square by 4a to infinity in this model. Then f of x decreases, f of x decreases from 4ac minus b square by 4a to infinity, to students minus infinity downwards. These are the characteristics of the two graphs, of course, which are not necessary for IIT JEE. Then for objective there are so many types of concepts are there, depends upon these graphs. In objective, in advanced level and in mains level, we have location of roots. This is the basic concept for the location of roots, and there is a characteristic that delta 1 plus delta 2 is equal to 0, delta 1 plus delta 2 greater than 0, and delta 1 plus delta 2 less than 0, less than equal to 0, greater than equal to 0, like that. So many characteristics are there in objective. To get the values in objective in easy way, except this one, this is not at all an NP for IP students. Just for objective only, I said the basic concept you can understand, try to understand, otherwise ask me later, no problem. Now let us try to discuss about the sums. Depends upon the theory, whatever I discuss. Now I want to discuss some examples and some sums in exercise also. Let us start first example, page 79, solved problems. Page 79. If I say each and every sum, I think you can do. Yes, I say each and every example. But in exercise 3 by I say some sums, and every sum I give homework to you in exercise 3b. I say each and every example. Page 79, example 1. Suppose that the quadratic equation have two equations have common roots. If write like this, ax square plus bx plus c equal to 0, comma bx square plus cx plus ca is equal to 0, have a common root. Have a common root. Then show that a cube plus b cube plus c cube is equal to 3abc. This is the conceptual question and this is the objective question also. Solution given q is I am writing. First of all, ax square plus bx plus c. We have discussed about the common root conditional theory. I said that a1x square plus b1x plus c1 equal to 0 and a2x plus bx plus c2 equal to 0. If the two quadratic equations have common root, then the formula is c1 a2 minus c2 a1 whole square equal to a1 b2 minus a2 b1 into b1 c2 minus b2 c1. Remember, the formula depends upon the formula. We should use the sum. We should do the sum. Ax square plus bx plus c equal to 0, and next equation is bx square plus cx plus a equal to 0. Write like this. Here a1 is equal to a, b1 is equal to b, c1 equal to c. Here a2 equal to b and b2 is equal to a2 equal to b, b2 equal to c and c2 equal to a. Formula I am writing. I said that while I said the theory, I said that please pronounce the consonant, pronounce the word, the formula like this. C1 a2 minus c2 a1 whole square is equal to a1 b2 minus a2 b1 into b1 c2 minus b2 c1. a1 b2 minus a2 b1 into b1 c2 minus b2 c1. Apply the formula. C1 A2, what is C1? C. A2, what is A2? CB. Minus C2 A1, C2 is A, and A1 is also A. Simply you can write A square. C1 A2 minus C2 A1 whole square is equal to A1 B2, and A into B2 means C minus A2 B1, A2 into B into A, AC minus BA into B1 C2. B1 means B, C2 means A, BA minus B2 C1. B2 is C and C1 is C. So C square. So anything, of course there is no question of common. This is whole square. CB minus A square whole square equal to AC minus BA into BA minus C square. Not possible. C square there is. Shall we take common? There is no possible. Here only we can take common. If there is any common chance is there. C1 A2, C1 means C, A2 means B, minus A1 C2. A1 is A and C2 is A. That's all. So C square B square minus 2A square BC plus A power 4 is equal to full multiply like this A square BC minus AC cube minus b square a square minus of minus plus bac square bac square. So ac cube, here bac square is there, a square bc minus a cube minus b square square. For everything a common is there, there is no common here. B square C square is there and 2A square BC, C square AB is not correct. A power 4 into, let us discuss about some. We got here CB minus A square whole square equal to AC minus B square into, somewhere mistake we have done here. A1 B2 minus A2 B1, A2 B1, here it is B square. This is the wrong. B square into BA minus C square. Now let us multiply. This is okay. This side once again we can do. This is A square BC, A square BC minus AC cube minus AB cube plus b square c square. B square c square both sides will be getting cancelled. That AC cube taken this side, we can write here a power 4 plus AC cube plus AB cube is equal to minus 2a square BC taken that side, it becomes 3a square BC. Now, better to divide with a, divide by a both sides. Divide by a both sides. It becomes a cube plus b cube plus c cube is equal to 3abc, which is the required result. A cube plus b cube plus c cube is equal to 3abc is the given the value which we should get. A is not equal to 0 because the quadratic expression is not at all proper there if a is not equal to 0. So that simply have divided. Students, if the same question arises in object, then what is the way? Simply put the shortcut x is equal to common. A plus b plus c equal to 0. A plus b plus c equal to 0. Whenever a plus b plus c equal to 0, we know very well a plus b plus c equal to 3abc. It is the 8th class formula. Now, let us discuss the second question. For what values of x the expression is positive? For what values of x? For what values of x the expression? For what values of x the expression x square minus 5x minus 14 is positive. Minus 14 is positive. This is 2 marks IMP model. According to our theorem, whatever I discussed, the proof alpha less than x less than beta, x less than alpha and x greater than beta, the concept we can do, but I don't want to say depends upon that concept, whatever the functions, domain concept and whatever the algebraical formula concept I discuss with you. Hereafter, whatever the method I am saying to follow that method, it is easy method, but whenever he is asking positive, simply you put the symbol greater than 0 for the expression. Whenever he is asking negative, simply you put the expression less than 0 for the negative expression. For positive, I am writing. Simply like this, you should write. You follow my method, it is better method. Of course, any method you follow, no problem. I am thinking that this is method. This method is correct. Easy way. For positive, I am writing 5x square minus 5x minus 14 greater than 0 input. Whenever x square minus 5x minus 14 greater than 0, you can write here by splitting the middle term of factorization x square minus 7x plus 2x minus 14 greater than 0. To get that, to know the values, you should not write, you never write this equal to there, simply leave like this. If you are having factors like raw like this, write like this, otherwise simply you do as x is equal to minus b plus or less root of b square 4x by 2, keep aside and substitute the value later. Whatever the method I am saying, do and follow this method only, don't get confused. Taken x common, x minus 7. Taken plus 2 common, x minus 7 greater than 0. That implies for interval we know that small letter we should write first of all. Small means here plus 2 means it becomes minus and minus 7 is plus. Minus 2 is smaller than plus 7. You can write x plus 2 and x minus 7 greater than 0. Therefore, x, this formula you understand, x minus alpha into if x minus alpha and x minus beta greater than 0, x does not belongs to alpha comma beta closed interval. Therefore, x does not belongs to here minus 2 comma 7 closed interval, or x belongs to r real number minus closed interval 2 comma 7, or x belongs to minus 2 minus infinity comma minus 2. This is open interval. Whenever is equal to is not there, then you should get open interval here, and here 7 comma infinity r. Now you can understand according to theorem x less than minus 2 comma x greater than 7. Any way you can write it. Whenever he is asking for positive, you can write greater than 0. Whenever he is asking positive, you can write greater than 0. Whenever he is asking negative, you can write less than 0. Okay, students, some models and theory today is it. Let us continue next class.